All right, well, welcome you to the start of section 4.2, and we're talking about the standard normal distribution here, which we have talked about a little bit before when we were using the empirical rule. So, with the standard normal distribution, we have data that's normally distributed, and the mean here in the middle is 0, and then we have a standard deviation of 1. So, this is a way to let us kind of scale different types of data to a similar scale. And what we will be doing now is we'll be trying to figure out probabilities. So with the standard normal distribution, this area under the curve, all of this stuff here is 1, and we get scores along the x-axis, and we'll find the area to the left of the score, to the right of the score, or between a couple of scores. And we'll also figure out, if we know a probability up in here, what does that z-score correlate to? So I'm going to be pushing you to draw pictures. If you ask questions, a lot of times I'm going to say, well, what's your picture look like? And the picture is really important for the understanding, connecting what we're doing with these Excel functions and tables really is what they generate from to our context of our problem. So for the standard normal distribution, we'll be doing the norm.s.dist function, and we put in a z-score, and then when we use the true, it tells us the area to the left of that z-score. If we know the probability up here, we can use a normal standard inverse, enter the probability to the left, and it kicks out the z-score for us. So that's sort of the basics, connecting back a little bit to what we have been doing, and I'm just going to grab a question here to start. Assume that the readings at freezing on a batch of thermometers are normally distributed with a mean of 0 and a standard deviation of 1. A single thermometer is randomly selected and tested. Find the probability of obtaining a reading less than 1.567 degrees Celsius. So essentially here we have a context where the probability of we're looking for a z-score of less than 1.567. So I'm going to get this here in Excel. Now, it's important to draw a picture, so I'm going to do that. I might use a stylus here just so they're a little bit better. It's okay if you draw sort of a rough one, but what we have here, here's our standard normal distribution, here's our 0, and we have a score of 1.567, and we're looking for this area to the left of it. Now we know that if we're within one standard deviation of the mean, we've got 68%, two standard deviations of the mean, 95%. And so we're looking for, this is going to be a lot of the probability. So a number maybe like 0.75 or something like that. So I'll do the probability that z is less than 1.567. And I'll zoom in on this a little bit. So we'll be using the normal standard distribution. And notice if I click here, it says z-score and then cumulative. So the z-score is the 1.567. And then true gets me the area to the left of that. I said 75%, it's like 94%. A little different. Round this to 4 decimal places, 1, 4. And a lot of the reasons we round to 4 decimal places is when we originally did this, we were using tables for it. So our normal standard distribution gets the area to the left of a z-score. When we start typing it in, it says normal standard distribution, z-score, and then cumulative. And so we'll be using true a lot on these, unlike with the binomial distribution where it's false if we want exact and true if we want a cumulative deal there. So I started with question 6 because it is a little bit easier. Here, question 5, it says assume the readings on a batch of thermometers are normally distributed with a mean of 0 degrees Celsius and a standard deviation of 1. A single thermometer is randomly selected and tested. Find the probability of obtaining a reading greater than negative 0.974. So go over here, maybe. So we have our normal distribution. Zeros here in the middle. Negative 0.974, and we're looking for the area over here. Now you'll notice that that's the area to the right, and our Excel function only gives us the area to the left of the z-score. So I'm at z greater than negative 0.974. So I have to be a little clever here. The total area under the curve is 1. And if I want the area to the right, I'll do 1 minus the area to the left. So in this case, normal standard distribution, negative 0.974. And then true gets me the area to the left. So we're using this idea of a complement, and what we're actually finding with our Excel function is this area here. And the whole area under the curve is 1, so we're going to do 1 minus that to get the area to the right. And this is why it's important that we draw a picture. So 8, 3, 4, 9. And a 7 will make that 9 go up. So we're really going to have 8350 as our probability. So our Excel function is limited in that it gives us the area to the left always. And so if we want the area to the right, we have to use the complement, do 1 minus that. And so 0.85, 83501. Anyway, it's important to draw the picture. If you don't remember how to get the ribbon up there in Excel, I go over here, customize the ribbon, which I'm selected somewhere funny. There it is. And you should have this draw enabled here. If it's not enabled, it won't be up there. This is one way to do it. Depends a little bit on your thing. Remember, the details of the picture aren't necessarily as important as having the picture. It's important for me and for you as we understand what we're doing here. So I'm going to stop this video and I'll come back and do another one on using the standard normal distribution. And this is really foundational for what we're going to be doing in section 4.3. And then as we kind of move on, we're just going to be building on these concepts. So take the time, understand what you're doing, draw the pictures. Anyway, I'll be back with another video. Let me know if you have any questions. Thank you.